Welcome to Chemsphere Hub. Okay, today I am going to present an important analytical chemistry topic known as chromatography. Chromatography is one of the most widely used techniques for separation, identification, and purification of chemical compounds. In this presentation, we will discuss its basics, principles, and different types and real-time life applications. Chromatography is very important analytical technique that has wide applications. Chromatography is a powerful separation technique used in chemistry and related sciences. It is mainly used to separate components of a mixture that cannot be separated easily by simple methods like filtration. So, chromatography plays a very important role in laboratories, industries, and research. So, they have very important role in chemistry, in biology, in medical sciences also. Now, chromatography can be defined as a technique in which the components of a mixture are separated. There are different affinities towards two phases, a stationary phase and a mobile phase. Because different components interact differently, so they move at different speeds and get separated. So, chromatography is a very powerful technique that is used to separate the components of a mixture. So chromatography is very important analytical technique. The basic principle of chromatography is based on adsorption or partition types. Some components of the mixture interact strongly with the stationary phase, while others interact more with the mobile phase. So each component moves with a different velocity, leading to separation. There are two main phases involved in the chromatography. The first is the stationary phase, which remains fixed and does not move, as the name shows that the stationary phase which cannot move, which remains fixed or do not move. And the second phase is the mobile phase, which flows over the stationary phase and carries the sample components with it. So two phases are important. One is stationary phase and the other one is mobile phase or moving phase. As their name also shows that fixed phase is stationary phase which remains stationary. However, the moving phase is a mobile phase as the name shows. And now we will discuss the mechanism of separation. In chromatography, the sample is introduced in the mobile phase. So as the mobile phase moves, the components immediately adsorb and desorb from the stationary phase. Due to different interaction, each component travels at different distances, so results in separation. Its basic mechanism or principle is the separation technique and the components, because each component have different properties and different velocities. So the due to interactions, each component travel at different distance and result in the chemical separation. Chromatography can be classified into several types based on the nature of the stationary phase and the mobile phase. Common types include paper chromatography, thin layer chromatography, column chromatography, gas chromatography, and high performance liquid chromatography. These are the main types of chromatography. First of all, we will discuss the paper chromatography. Paper chromatography is a simple and low cost technique. Here paper is used as a stationary phase and the solvent acts as the mobile phase. So there are two phases. So one is stationary phase and the other one is mobile phase. So paper acts as stationary phase and the solvent acts as mobile phase. It is commonly used to separate dyes, inks and amino acids. So the other chromatography type is the thin layer chromatography. A thin layer chromatography it is a thin layer of silica gel or alumina that is used at the stationary phase. TLC is faster and more efficient as compared to paper chromatography. It is widely used in drug analysis and reaction monitoring. So, paper chromatography is the very basic technique, and TLC, in this case, the thin layer chromatography, it is termed as, and a thin layer of silica gel or alumina is used that serve stationary phase, and TLC is faster and more efficient than the paper chromatography. So, it is used in drug analysis and reaction monitoring. It is very helpful technique. The RF is very important factor. It is a very important parameter. It is termed as retention factor or RF value. It is calculated as the distance traveled by the solute divided by distance traveled by the solvent front. As each molecule, each component of mixture have the different nature, which are samples are the solute and the mobile phase is solvent, and the solvent is taken from where the maximum solvent moves and it is marked as solvent front. Then the solute mixture, sample mixture is also marked. So each component will move at different distance. So RA value can be find out, and it is very important. It is calculated as the distance traveled by the solute divided by the distance traveled by the solvent front. So RA value is very useful in the identification of a compound. Now we will discuss the column chromatography. Column chromatography uses a packed column filled with stationary phase. Here the stationary phase is column shaped as we discussed in paper and chromatography. The paper is the stationary phase, and in TLC thin layer chromatography alumina or silica are used for the thin layer. which also act as stationary phases, and then the column chromatography is used that use a packed column filled with stationary phase. The mobile phase flows through the column, separating the components, and it is mainly used for purification of components in organic chemistry. Now we will discuss the gas chromatography. In gas chromatography, the mobile phase is an inert gas such as helium or nitrogen. Gas chromatography is used to analyze volatile compounds. So it offers high sensitivity and accurate results. So gas chromatography is very useful and it is very sensitive technique, but it is used for volatile components, and here the mobile phase is a gas. It is the gas mobile phase is used for mobile components so that the components can be separated by the use of gas chromatography. And it is very powerful and highly sensitive and accurate technique. Now we will discuss the HPLC. HPLC is an advanced form of liquid chromatography. The mobile phase is pumped at high pressure through the column. HPLC is widely used in pharmaceutical industry, clinical and environmental analysis. They also have very high efficiency. Chromatography has a wide range of applications, such as it is used in drug testing, food quality control, environmental monitoring, forensic science, and biochemical research. So chromatography is a very important analytical investigation that is very useful, and it has very wide applications. So as chromatography offers many advantages, it is very accurate and sensitive technique. Very small amount of sample is utilized and it can separate complex mixtures efficiently. And despite of its advantages, chromatography has some limitations. Advanced techniques like HPLC and GC are expensive. They also require skilled operators and careful maintenance. Safety is very important while performing chromatography. So always wear gloves and safety goggles. Avoid inhalation of solvent and a disposable chemical waste properly. So to summarize, chromatography is an essential analytical technique. It works on the principle of different movement of components. Different type of chromatography are used for different analytical purpose. Thank you for your attention. If you have any question, I will be happy to answer that. So